So now that I know the market value of the debt, and I know the market value of the equity, remember that was the market value of the common and the market value of the preferred, I can go ahead and I can identify my weights. And I know that E is 229.763, P is 10.75, D is 58.733. Add those up, and it tells me V is 299.245. It's simple math at that point. And if I know what V is, and I know what each of the inputs to V are, I now know what the weights are, because I simply can take E divided by V, P divided by V, D divided by V, and it gives me these weights in the weighted average cost of capital. I now know the weights, I know the tax rate, and now I have to figure out RE, RP, and RD. And these are simply the best estimates I have for the cost of equity, common equity, the cost of preferred, and the cost of debt. Okay? Now we'll talk about how to get these in just a moment. Any questions about how I'm thinking about this? Carol, are your eyes bleeding yet? Good for you. I was going to ask Diana. I was afraid to. Okay. So I want to take each one of those costs in turn, and I'm going to tell you that there's a best way, or the most accurate, a less accurate, and then maybe a not very accurate way. And you will always use the best way if you have the information available to use the best way. And when it comes to the cost of common equity, or RE, the best way of thinking about this is an opportunity cost of common equity. When we're talking about market values, our best way of looking at anything and everything is a real opportunity cost. Well, how do we come up with that real opportunity cost? We use a construction referred to as the capital asset pricing model, or the CAPM construction. And we calculate RE using CAPM by taking, and I'll explain all this in a moment, RF plus beta times RM minus RF. What the heck does any of that mean? Well, the capital asset pricing model, there's a lot of information out there about the capital asset pricing model. You don't need to go into a lot of it, into deep dive on this, and I'm not going to either. I'm not going to go through the theoretical foundations of it, other than to tell you that it is as close as we have to a perfect opportunity cost of equity or common equity capital. The components, or the inputs to calculating it, are RF, beta, and RM. So let me explain to you what each of those components or inputs means. RF is the risk-free rate in the investment market at any given point in time. Well, what investment do you think you might be able to make that would be the closest to being risk-free? Any ideas? If you haven't had to, pardon me?
The Treasury bond, United States Treasury bond.
And the shorter the duration, the less possible risk, right?
No. Isn't the 30-year the safest?
Well, no, the 30-year, because it's so far out in time and interest rates might be changing, it's going to be the least safe of all the federal or Treasury instruments. The shorter the time frame, the lower the risk component, or the more risk is built into it. So we think of the risk-free rate as being somewhere between the 2-year and the 10-year Treasury rate. Okay, right now that's about 2.3%, give or take. So what's RM? It's the industry average return on that type of stock. So let's say that we're dealing with a auto manufacturer. We would look at, for RM, would be the average rate of return for companies in the automotive manufacturing space. So RM is the industry average. So if we take RM minus RF, so taking the industry average return, which has some risk built into it, right? Because auto manufacturing, and almost everything else, has risk built into it. We take RM minus RF, or the risk-free rate, we get an equity risk rate based upon the industry. Not the company, but the industry, because we're using the average industry return minus the risk-free return in this part of the equation. So what happens when we interact that with beta? Well, what does beta stand for? Do any of you know what beta represents in this kind of a construction?
Company's risk compared to the industry risk.
Exactly, David. So a beta factor of 1 is where this company, and beta is specific to the company, is where the company's risk volatility measure is equal to the average in the industry. So an industry average volatility measure would be 1, which means that that company would have a return expectation of RM. If it has a greater return expectation than RM because of risk, that's going to be because the beta factor is greater than 1. If it has less, it's because the beta factor is less than 1. So the sum of these components gives us RE as perfectly market-oriented and opportunity cost as we can find. Okay? And in most of the casework we'll do, and most of the example work we'll do, you will have all of the components to RE using the CAPM model. If I tell you that a 10-year treasury is yielding 2.3%, that's RF. If I tell you that a company's risk volatility measure is 12% less than the average for the industry it's in, well, the average is 1, and if it's 12% 1, then it equals 0.88. The beta is 0.88. If I tell you that the average expected return on common stocks for a particular industry is 11%, that's RM, because that's the average for an industry. Sometimes in these cases, I spell it out very clearly to you. In some cases, I use other terminology, and I do that purposely because you don't always hear it referred to in the exact textbook classical style when you're dealing with business. So I try to introduce some of the different ways business people talk to you about it so you learn to recognize it. Okay?
Can you repeat what you said just about the beta?
Certainly. So, Kate, the beta factor is a company's risk volatility measure. And it's literally measuring the price volatility of the common stock. And the riskier the company is, the more volatile the price of the common stock will be. Okay? When a company's beta, or risk volatility factor, is equal to 1, it means that the volatility is synonymous with the volatility of the average of the entire industry. In which case, it's going to have a market return equal to that of the entire industry. If the volatility is greater than the volatility of the industry, it'll have a beta greater than 1. If the volatility is less than the volatility of the industry, it'll have a volatility or beta of less than 1. Let me give you an example. So we have automobile manufacturing in the United States. I think that we're going to suggest that Ford, General Motors, and Chrysler, the big three, are all relatively similar, but that Ford has a lower price volatility than Chrysler and General Motors. If you looked at their price volatility over the last 10 years, you would see that. And we see a sign of that by virtue of the fact that Ford didn't need to take bailout money in 2008, and when the others needed to take bailout money. In fact, General Motors actually did a staged bankruptcy, right? So the average of all of the industry would include their averages, but Ford is probably less volatile than the average of them, and Chrysler and General Motors are probably represent the average. But then you've got this little company out there, this little upstart electric car company named Tesla. And I think we would agree that because of the personality of its owners, the cutting edge nature of its designs, I mean, are you kidding me? A Hypertruck, really? So and everything, I think we would agree, and its debt component, it's much more volatile than the industry average. So General Motors and Chrysler probably have a beta factor of about 1. and their expected return is probably equal to RM for the industry. Ford has a beta factor less than 1, and its expected return is probably a little bit less than the industry, but it's not nearly as risky a bet, if you will. Tesla, on the other hand, and I am all about Tesla. I dig the technology. I love the style, absent the Hyperloop debacle or the Hypertruck debacle. And some of you might like the Hypertruck, but I don't know what they were thinking. And it's going to have a beta factor greater than 1. Does that help? Cool. Okay, so there's another version of RE. RE using CAPM is best. RE using the dividend yield or Modigliani and Miller construction is second best. And if you don't have the components for CAPM, you can rely on this construction. And I'm not going to spend much time here right now, in part because we rarely will deal with this, and we'll spend more time with this when we talk about the Gordon growth model, because this is a derivation of the Gordon growth model. Okay, so I'm going to pass this by for the moment. But notice that you have a second best here that you can rely on if you need to. There literally is no good third best. Although I guess you could say simply taking the dividend that a common stock pays and dividing it by its market price would give you a rate, and that rate would be a return on the common stock based upon the dividend, but it's incomplete because it's only based on the dividend, and most companies don't pay dividends. So the third best is a poor alternative. So normally we're going to think of RE as coming from the CAPM construction using this equational form. And this just talks through some of what we just walked through together. And this then takes us to preferred. Well, I'll tell you that we want an opportunity cost for preferred, that's RP. There is no CAPM construction version for RP because there's no beta value that is publicized and estimated for preferred stock. The beta value is almost exclusive to common stock in terms of being able to find it online. And you can go to Yahoo, Google.com, Finance, whatever, and you can find a beta value for every publicly traded common stock out there. And I'll buy you lunch someplace really nice if you can find one for a preferred stock. They're just not publicized. You could calculate one if you looked at the change in price on a daily basis and took the standard deviation from the mean of that and then took the variance of that. And that's what the beta actually is, and this is a statistical measure. But for our purposes, we're going to take the preferred dividends paid by the company divided by the value of the preferred stock. So let's look at that for this company for a minute. We've got the preferred dividends paid by the company, which was 0.2, divided by the value of the preferred stock, and that's going to give us an RP, which if we go down here, we can find cost of preferred, or RP. 0.2 divided by 4.945 is 0.40%. That's not 40%. It's 0.4%, or 0.4%. And that would be RP. And if we found the RE using the CAPM structure, and remember here we have RM, the market returns, RF, and the beta value, we can then put together, and I simply restate them right here, we can put together RE using the CAPM construction. So that's what's going on in these cells. I guess you could take as a second best alternative the dividend rate of the preferred, which is an imperfect substitute than the preferred dividends paid divided by the value of the preferred, because this rate is applied to the original dollar amount the company raised in preferred stock, not the market value of it in today's market. Any questions about where we are so far? We're almost at the end, I promise. You guys still breathing? Michael looks like she's breathing. Okay, good. Let's go a few steps further. Final cost is RD. You're going to see in the material that I have for you, current yield on an annualized basis is equal to RD. So if I tell Diana that a certain type of debt would cost 7% in today's market, regardless of what it cost when it was originally issued, but it would cost 7% in today's market, that's current yield or RD. It's the opportunity cost of that kind of debt for that kind of company today. And the only difference between RD and YTM is in the bond equation, YTM is a periodic rate and RD is an annualized rate. So if we take an annualized YTM and an annualized RD to the same number. Okay? Any question about that? I'll show you some numbers here in a moment. Well, if I've gone through and done the calculations we've just talked about, the three different types, I've calculated RE, RP, and RD, and I know my tax rate, I now can put all of that together, knowing my weights in the WACC equation. And I took the value of the common stock, which is 229.76, divided by the value of all the capital components, and multiplied it by RE. And then I did the same thing for P divided by V times RP. The same thing for D divided by V times RD times 1 minus our tax rate. So because after cost, or after tax, we have a 16.95% cost of capital. And now Carol's eyes are bleeding. Okay? So I know that aside from wanting to say, what the heck did you just talk about? Aside from that question, do you have any questions you can articulate for a moment? Okay, so we're going to walk through every one of these steps next week as well. Those of us that get together next Monday night will also walk through these steps. If you'll go back and look at this video and or the other videos I have on here on Canvas for WACC for you, it'll walk through all of these steps.
And you said we're going to do a formula on Excel as well, right?
Yep. And I'll show you that in just a moment. And when you do your Excel spreadsheet, you're going to walk through all of these steps. By the time next class is over, you will have gone through this probably 6 or 7 times, and it will have been etched more dutifully in your memory, although I'm not naive enough to think it'll be permanently etched quite yet. My goal is by the time we're done, you will never forget WACC, because believe it or not, you will use weighted average cost of capital in your careers. I would be shocked to find otherwise. Okay?
Rick, regarding next Monday, it's a holiday, so are we gonna?
Yeah. So, in fact, Andrew, maybe you're the one that brought this out to me a few days ago. Somebody did. I don't recall who it was. Next Monday is a holiday. I am certainly willing to do a review for all of you on Monday night, but I am also confident that some of you are probably preferring to have that day off. Well, you probably prefer to have any day off from this stuff, but and maybe have plans. So let's think of an alternative day that we can have that review. It can't be Tuesday night because, well, we have class on Tuesday night. I would prefer that it not be Friday night. I have another one for a different class on Thursday night. Okay? Would you prefer Saturday evening or Sunday evening for this kind of a review? Or would you prefer to not have one this week? Let's start by who would prefer to not have a review this week? Let me see hands.
I don't think I'm going to know until I get into this, but
yeah.
I mean, I feel like, you know, we have the WhatsApp and we have a lot of resources. So I guess me personally, I feel like, you know, we've gotten to a few more complicated things this week than last week, but I'm not super concerned.
Okay.
Needing it.
let's do this, because honestly, I prefer to not do Saturday or Sunday night, just like you wouldn't, I'm going to guess. Okay, Sundays I try to keep for my family and my faith. So let's do this, because I want you to have the opportunity to ask questions and get answers before your homework is due, and I mean a decent amount of time. Rather than hold a review before the homework is due and before our next class, I will go ahead and extend the due date for this week's assignments to Wednesday night, not Tuesday night. So the first part of our class will be our review, and you'll then have until the next night to get those items completed. Should that satisfy the need? Okay, I see that's not.
Absolutely.
Okay, I will do that. And if I haven't updated those due dates by tomorrow morning, will one of you please harass me to get me to do so? Okay, so I think that's probably the best solution.